welcome. Give this a few minutes for people to get in. I know I started the stream early today. All right, folks, we'll be starting in about 2 minutes. All right, folks, welcome. We're going to get started. Today is day 19 of remote learning, and today's joke of the day is, what do you call a cow with no legs? Ground beef. That was submitted by one of my grade 9 students. Happy Friday. Simplify that like button to show your support. Big thanks to Jawad for sharing that joke. Pretty nice follow-up to Wednesday's joke. If you have others that you'd like to see on the channel, please send them to me by email. In today's lesson, you might have noticed there was a link to some other YouTube stuff that's not mine. I've decided I'm going to start sharing some links to things on YouTube that are math and science related. There's a channel I follow called Primer that's really good. And they just did a video about computer simulations for spread of diseases in epidemic, endemic, and eradication scenarios. And it's not specifically about COVID-19, but it starts to answer some questions you might have about what does this look like and how can we get rid of COVID-19 eventually. So hopefully you'll find that interesting. The channel's called Primer. There is a completely unrelated movie called Primer that also happens to be one of my favorite movies. And so when I was looking at the channel name, putting that link in, I was like, oh yeah, Primer, that was such a good movie. So I also put a link to the movie up in the classroom. It is a really cool movie, but it can be a little bit confusing. I've not met anybody who fully understood it the first time they watched it. So if you have some time over the weekend, you can watch it and rewatch it. It was such a good movie that I actually watched it and then immediately rewatched it and then immediately watched it for a third time. So by the time I got up from my chair after having sat down to watch the movie, I had watched it 3 times all the way through because it was such a neat movie. So hopefully you can enjoy those things over the weekend. Today we're going to do some work on solving rational equations. We're really well prepared for this skill. It really draws on some other things that we've done. So hopefully you'll find that it fits in well with what you already know. So without any hesitation, let's get right into things. Let me just line this up. Oh, that is not lined up at all. There we go. And excellent. All right. So in the Google Classroom, there's a document called Day 5, Solving Rational Equations. That's the one we're going to take a look at. All right. So just like with logarithmic equations, when we're solving rational equations, we do need to be careful to check whether our solutions are admissible or not. And so that's really the main key. Other than that, solving rational equations is basically a little bit of algebra to simplify and then solving a polynomial. But we do need to check the validity of solutions. So let's take a look at the first example here. You can see that we have x minus 2 over x minus 3 equals 0. And it's useful to think of this as f of x equals x minus 2 over x minus 3. Because we already know a lot about rational functions. And in particular, we know that if we want to find zeros of a rational function, we're looking for factors of the numerator that are not present in the denominator, right? Any factor in the numerator corresponds to a 0 as long as there isn't the same factor in the denominator. And so that means that when we want to solve a rational expression equal to 0, we know we're really just looking at factors of the denominator. And if you look on the handout there, you can see the graph of this function. There's the asymptote at positive 3, and there's the 0 at positive 2. And so you can see, oh yeah, the only place where this is equal to 0 is when x is equal to 2, and we get 2 minus 2 equals 0 over 2 minus 3, negative 1. 0 over negative 1 is indeed 0. So that's going to be our general pattern. So we set x minus 2, or the numerator, equal to 0. We solve, and we'll get x equals 2. So that's our general idea. Obviously, this is a very simple one. It's going to get a little more complicated, but that's pretty much what we're going to do the whole way through. I do want to show you one other quick, simple example to illustrate something. So what if we have x plus 4 over x plus 4 equals 0? Well, we might go, okay, set x plus 4 equal to 0, solve, we get x equals negative 4, therefore x equals negative 4 is our solution. But here we run into a problem. Our denominator also has x plus 4. And that means if we sub in negative 4, we get 0 in the numerator, but we also get 0 in the denominator. And 0 divided by 0 is undefined. It's not equal to 0. So this is an inadmissible solution. They don't occur super often with rational equations, but we always need to check them. And what we're going to do to check them is, before we even start the simplifying and solving, we're going to look at the denominator and identify what the inadmissible values are. So here I look at the denominator, I go, oh, x plus 4, that's going to be 0 when x is equal to negative 4. Therefore, x equals negative 4 is inadmissible. All right, so that's the idea. So let's take a look at some slightly more difficult ones. So this next one here, maybe I should have called this example 1b. That way I don't mess up numbering on the page. So number 2 on your page, we have 1 over x equals 2 over x plus 1 over 1 minus x. All right. So you'll notice this isn't equal to 0. Well, we want it equal to 0. You'll also notice there's a whole bunch of different fractions with variables in them. We don't want that. We want a single fraction equal to 0. So we're going to start. We're going to start by rearranging here. Move the 1 over x to the other side. And I'm going to do these 2 steps in 2 separate pieces. You can start combining them if you're comfortable with that. 1 over x minus 1 over x is 0. 2 over x minus 1 over x, well, they have a common denominator, so that's just going to be 1 over x. I'm going to leave a lot of space here. You'll see why in a moment. I need to find a common denominator for all of these. All right, so now I'm looking, I've got it equal to 0, but I don't have a single fraction over here, and I want that single fraction so that I can use what we know about rational functions. So I need a common denominator. So we have x, we have 1 minus x, and this is just over 1. So I'm going to multiply this one by x over x. So that'll get me a common denominator. I'm going to multiply this one by 1 minus x over 1 minus x. That'll get me a common denominator. And I'm going to multiply this one by x times 1 minus x over x times 1 minus x to get my common denominator there. All right, so a little bit confusing looking, but it's basically just finding the common denominator. Okay, so then we get 0 equals 1 minus x is going to be our numerator from this one. X minus x squared is going to be our numerator from this one. And x is going to be our numerator from this one. And because they're all having the same denominator, we can just put that in here. So there we go. 0 equals, now we can clean this up. Minus x plus x is 0. So we'll get minus x squared plus x plus 1 over x times 1 minus x. And we don't need to expand the denominator here. It's not helpful, so we won't spend time doing that. So now I want to try and factor this. I think it through. I don't see any nice factorization of that one. So we're going to go to our quadratic equation. So therefore, 0 equals negative x squared plus x plus 1. And quadratic equation says x equals plus or minus b, minus b plus or minus square root of b squared minus 4 times a times c all over 2a. It's actually kind of hard to do that in English for me. I learned it in French in high school. So I remember moins b plus moins racine carrée de b au carré moins 4ac tout ça sur 2a. So a little bit hard to translate, but there we go. And now we can just grind through that, and we get negative 1 over negative 2. So we'll make that positive. Make it over 2 plus or minus. The negative just keeps that plus or minus. Square root of, well, 1 squared is 1. Negative times negative is positive, so we'll get 1 plus 4, so that is 5. All right, so 1 plus or minus root 5 all over 2 is our solution for this one. And we need to check, is it admissible? Well, anytime x is 0, we'd be inadmissible, or if x is 1, we'd be inadmissible. None of those are the case, so we are just fine here with this solution. And oops, I'm off the page there. Do it like that. So x is 0 would be a problem. X is 1 would be a problem for this denominator. Neither of those are an issue. So this is our solution. There are two possible answers, x being plus or minus root 5 over 2. All right, give me a 1 in chat if that's making sense so far. And if you have a question, please type that in the chat instead. Thank you, Daniela. Looks like the lag time on this video is super short. That's awesome. Thank you, Caitlin. All right. So let's take a look at number 3 from the worksheet. And I'm going to do this one just a slightly different ordering. And this is the ordering I would recommend, is get in the habit of, when you look at one of these questions, figuring out what the inadmissible values are right away. So we have 1 over x plus 1 over x minus 13 equals 1 over 42. Therefore, x equals 0, x equals 13, inadmissible. So I'm not going to wait till the end. I'm just going to figure it out right away. What are the inadmissible values? Well, this one would be undefined if x was 0. This one would be undefined if x was 13. This one is always defined. So those are our two inadmissible values. Okay. So now we just need to find that common denominator. So 1 over x times x minus 13 over x minus 13. 1 over x minus 13 times x over x equals 1 over 42 times x minus 13 over x times x minus 13. And if I want the 42 in both of these, which I do, I'll need to go 42 over 42. And same here, 42, we can just make this 42 up here, and x times 42 down there. All right, so that gets us our common denominator. I'm going to be honest with you, when I do these, I basically never write out all of this stuff. I just look at it, I go, okay, this one is x, so I'm going to need x minus 13 and 42 on the top. And so I just go, okay, 42 times x minus 13, and just write it from there. I don't go through and show all of this stuff because it takes a lot longer to do. And so with the next question, I'll show you how to do that. But I wanted to show you a few of them where you see every step first. Okay, so moving along. So here we will get 42 times x minus 13 from the first one, plus 42 times x from the second one, equals, and so we'll just bring this over with subtraction. X times x minus 13 is x squared minus 13x. And that's all being subtracted. So these brackets are really important. Equals 0 over 42x times x minus 13. All right, so all the denominators are the same. So we bring that over and we're in good shape. Okay, so therefore, it's just the numerator equal to 0. And we can start to simplify this. That becomes 42x. What's 42 times 13? Well, 2 times 13 is 26. 4 times 13 is 52. So 520 plus 26, 546. Oh, and we're subtracting it. Minus 546 plus 42x minus x squared plus 13x. And then we can simplify that down. We'll get 0 equals 42x plus 42x. That's 84x plus 13x is 97x. So we have negative x squared plus 97x minus 546. Okay, so I'll pause there. If you have questions, I'll take them right now. If that's making sense so far, feel free to give me a 1 in the chat. Thanks, Daniela. Thank you, Caitlin. Okay, so now we just need to solve this. It's possible that there's a factorization that works out nicely. I don't see it off the top of my head. Yeah, 5 times 92. That's not going to work. 6 times 91. Let's just try that. 6 times 91 equals 546. Oh, sweet. Okay. So I looked at this and I was like, 97 is just a bit less than 100. This is a bit less than 600. So maybe I need to do this times 6. So it turns out if you split it up, negative x plus 6, yeah, that should work, x minus 91, then I think we get it. So 6 times 91, or 6 times negative 91 is negative 546. This will be 6x. These two negatives will make a positive, so that'll be 91 plus 6, 97x. And then negative x times x is x squared. So some good news for us there. We've got it solved. Therefore, x equals 6 or x equals 91. And we'd said at the beginning of this one that 0 and 13 were our inadmissible values. So we did that back here. 0 and 13 are the inadmissible values. We got neither 0 nor 13. So we are good to go. That is our final answer. Admissible, admissible. All right. Okay. So hopefully you're seeing that mostly this is about solving polynomials. So far we've had all quadratics. If we had a cubic, we obviously couldn't use just the quadratic formula to solve it. But if we have a cubic, then we can use the other techniques we've learned for solving cubics, and those will work just fine. All right. So why don't you take a moment and try question 4 on your own. So see if you can do question 4 from the page, and let me know what solution you get. I'm going to wait about 30 seconds, and then I'm going to start doing it on here as well. And that way, if you run into a roadblock, you can check your work against what I'm doing. And I'll write down what the question is in case anyone doesn't have the handout there. So example 4, we have x plus 3 over x minus 4 equals x minus 1 over x plus 2. All right, so I'll give you a few seconds to get started on that one, and then I'll work on it as well. All right, so once you have a value for x that solves the equation, just type it into chat. Cool. Okay. So Daniela, that's really close. Caitlin, you have the numerator correct. So it looks like we just have a denominator to solve here. So let's go through it together and we'll take a look. So first thing I did here was I moved the right-hand side fraction over to the left-hand side so they're both together and I have it equal to 0. Here I did the common denominator, and I mentioned last time that I do it in a slightly faster way. So I want to show you what I did here. So normally I'd have to multiply this by x plus 2 over x plus 2. But the thing is, I know that in the end I'm going to have a common denominator, right? That's the whole point of finding a common denominator. So instead of creating the whole denominator here and then recreating the exact same denominator over here, I'm just going to make one big fraction. I'm going to say, okay, my denominator is going to be x minus 4 times x plus 2. I put that in. And then what do I need for this fraction to get to that denominator? Well, I need x plus 2. So I'm going to multiply the numerator by x plus 2. There it is, x plus 3 times x plus 2. For this fraction, I already have the x plus 2 in the denominator. I need x minus 4. So the numerator is going to get multiplied by x minus 4. And then instead of writing out all the denominator math, I'm just going to say, hey, I know this is the final denominator, so there it is. Okay. So then I just need to simplify. So Caitlin and Daniela, did you get to this step and have the same thing that I have, or did you have a question earlier than that? If you got to this step and that matches what I have, if you can just type a 1 into the chat. And if you have a question, yes, Daniela, okay. How about you, Caitlin? Did it work out this far, or is there something you want to change already? Cool. All right, we're good. Okay, so then x plus 3 times x plus 2, that's x squared plus 3x plus 2x, so 5x. And then 3 times 2 is 6. So we've expanded that. We get this here. For this second part, it's really important to have the brackets around everything when you expand it, because we're subtracting this whole multiplication, right? This whole fraction was getting subtracted. So this entire multiplication has to be subtracted. So I usually like to put the brackets first and then multiply and fill in inside. So x times x is x squared. Minus 1 times x, that's minus 1x. Minus 4 times x is minus 4x. Minus 1x minus 4x is minus 5x. And then negative 1 times negative 4 is plus 4. But this is all in brackets. It's all going to be subtracted. So then we have x squared minus x squared. That's 0. 5x minus negative 5x. So that's like adding 10x. And Caitlin, if I was guessing, I would suspect that you just subtracted 5x here. Actually, maybe not. Nope, that might not be it. Anyway, so we're subtracting negative 5x, which is like adding 5x to 5x, gets us 10x. And then 6 minus positive 4 is 2. Move the 2 over, divide by 10, we get negative 2 over 10, or negative 1/5. So Caitlin and Daniela, did that help you out to see what happened with your solution, where you were right and what you need to change? Cool. Okay, so Daniela, that helped you out. How about you, Caitlin? What do you do with your denominator before you expanded out the numerator? Good question. So because it's a rational function, if it was equal to y instead of equal to 0 or equal to f of x, and we were talking about the whole function, if we want to find the 0 of a rational function, we're looking for the zeros of the numerator, right? That's going way back to when we were in class and we talked about how the numerator factors give us the zeros, the denominator factors give us the vertical asymptotes, and if there's a factor that's in common in both the numerator and the denominator, it's going to give us the wholes. So here, when we set it equal to 0, we are looking for the zeros of that function. In other words, we are looking for the factors of the denominator. And so that's why here I can just say, therefore, the numerator equals 0. Oh, sorry. I think I just misspoke. We're looking for the factors of the numerator to get the zeros. So when we have it equal to 0, we can just say, okay, the numerator is equal to 0. The denominator doesn't matter because it's the part that tells us about vertical asymptotes, not about zeros. And we're just looking for where the zeros are. Now, we do need to be a little careful, right? Because if we get the same factor in the numerator and the denominator, then that's a whole. But we already checked that when we did the inadmissibility checkup here. We said, what are the things in the denominator that will make zeros? Oh, that's 4 and negative 2. Okay, so those ones we can't allow, but any other solution is fine. And here, because we got negative 1/5, that's not 4 or negative 2, so it is admissible. Does that make sense, Caitlin? Was there something else you wanted to ask to get some further information about it? Cool. Okay. So that gives you the general idea. We check and we find the inadmissible values. Please make it a habit to do that first. If you do that first, you will find that it saves you from forgetting it. So always make a point finding the inadmissible values first. We go through, we do the algebra to get a single polynomial divided by a single polynomial, and then we solve the numerator polynomial to find the values that work and obviously check if they're admissible. So those are our steps for solving a rational equation. Sometimes students ask, why on earth would we want to solve a rational equation? It's a good question. It turns out that they are a pretty good model for a lot of situations that occur in the real world. And so I want to close today with an example of a question that if you were working in chemistry or you were working in a large zoological aquarium or something like that, you might have a question like this. So this is question 5 from the handout. It's the one about salt water, and it's at the top of the second page. So it says salt water is flowing into a large tank that contains pure water, in other words, water with no salt. Concentration of salt C, So C is concentration of salt in the tank at T minutes. So T is the number of minutes, is given by the equation C of T equals 10T over 25 plus T. So C measures in grams of salt per liter, and we want to know when does the salt concentration, so C equals, when does it reach 3.75 grams per liter? So we want to know at what time is that going to happen? Well, we can use the equation here, and we can just substitute in what we know. So we know that the concentration is going to be 3.75. And we don't know the time T. That's what we want to find. So there is our equation. We need this equal to 0. So we'll go 0 equals 10T over 25 plus T minus 3.75. I'm going to make it a fraction as well, so it's over 1. And now we can look at combining this into a single fraction using common denominator. So my denominator is going to be 25 plus, that's a T, 25 plus T times 1, so just 25 plus T. 10T already had that as a denominator. Oh, keep writing L instead of T. There we go. So 10T already had the correct denominator. 3.75, we'll need to multiply that by 25 plus T to get this common denominator. So there we go. And now we can just start simplifying it. And we know, as always, that it's the numerator that sets us up for the zeros. So we're going to set the numerator equal to 0, 10T minus 3.75 times 25. That is 93.75. Minus 3.75 times T is negative 3.75 T. And then 10T minus 3.75 T is 6.25 T minus 93.75. Finish solving, we get 93.75 over 6.25 equals T. Probably out of view here. Is that better? Yeah, there we go. And therefore, T equals, let's calculator this, 93.75 divided by 6.25, 15. And since T is in minutes, that is 15 minutes. So therefore, it takes 15 minutes to reach 3.75 grams per liter. So as you can see, there are situations where we want to be able to do something like this. Rational functions are actually a really common scenario to occur. There's a lot of physical phenomena that are described accurately by rational functions. So they can be pretty useful for us. We don't have time to really dive in and spend 3 days exploring them, unfortunately. But it's pretty likely if you continue on in science or engineering or business that you'll encounter them quite a bit. They're very, very common in economics. So if you're headed that way, you will definitely see more of them. All right, so that's it for stuff I wanted to do. If you can give me a 1 if you have no further questions and you're feeling ready to take on some of these yourself. And if you do have a question, please go ahead and type it into the chat. Thank you, Caitlin. Thanks, Daniela. All right, folks. So that's it for today. Thanks to those of you who signed up for the additional assessment. You should have received an email from me yesterday with some steps that you need to take in order to make that happen. So we'll be doing that next week. If for some reason you wanted to sign up but haven't, if you can send me an email, go into the Google Classroom and read the post about the optional assessment. You don't have to do it, but if you want to, it's available. And send me an email with the topics that you've picked. We should still be able to fit you into one of the groups. All right. Thanks a lot, folks. Have a great weekend, and we'll see you again on Monday.